Yeah, I'm recording it. Programming for VFX. So we use VEX and Python for creating a lot of visual effects content. VEX is a language within Houdini ecosystem. So we use it in, so it's kind of like a language based on C and C++. It used to be a shading language. They used to create shaders like with this language, but now it just, we use it for everything. It's a very fast program. It's programming language, I should say. It's if you want to make something that applies and functions very quickly, it's your option. Python is more of a, it's generic. It's a higher level language. It's closer to our human language, and it's universal. So like if you so at some point we start with VEX because it's inside Houdini and it's like makes a lot of sense for those of you who has already started working with Houdini. And then we move to Python for creating more complicated stuff. And then you will see that the same knowledge that you get here from using Python in Houdini will apply to any other packages like Nuke, if you want to do Python programming in Nuke or in Maya. So where we use VEX, or when we use VEX, when we use Python. In general, so in Houdini you see a lot of nodes, okay? Python is really good if you want to, like, if you have like 50 nodes and you just say, oh, instead of all these 50 nodes, I can write like half a page of Python code and just like condense it. So Python is really good for managing complexity, okay? But it's not very fast. But if you want to create something like a tiny code that suddenly functions very fast and does something in one of your specific nodes, that's when we use VEX. VEX has a visual interface as well, which we call it VOPS, but at the moment we start with just the scripting one. So that was a bit of history. So let's start with a very simple sphere. Okay, I'm gonna open Houdini, which is already open. Where is my Houdini? There it is. Okay. Let's start with adding a geo. I call it, I don't know, VEX programming session 1 or whatever. So just add a sphere here, or any object. You can add the pig head or whatever. So I'm gonna make it polygon mesh. So these are the stuff that. So you guys realize that I have, again, for those of you who are still not familiar with the way I work, I like my node editor to be clean and neat, and I don't want to see parameters constantly up there. So that's why I always close this. Whenever I need parameters to load, I just press P on my keyboard. They just load, and if I don't need it, I press P and they go away. So that's easy. So I just like, let's start to see how, let's change the color of these points. So what is a geometry? So start from the very basic functional concepts. So every time that we work in Houdini, I always tell you. So we've done complicated things in Houdini so far. You have created explosions and fire and all sorts of things. But now I just want to step back and think deeply. So the first thing that I want you to pay attention to is that the object that we are just seeing is not It's just a bunch of points. So I'm going to turn on the point number. You see that these points have an ID. So like point 46 is connected to point 47, and that one is connected to 71 to 70. So they all together create this, face over there. So, and these points, each one of them has is located in space somewhere. Okay, so your friend, one of closest friends in Houdini is this geometry spreadsheet. When you click on that, you see like, okay, so each one of these points have a location in space. A location is basically just x, y, and z. So let's go back to where I was looking at point, let's say point 46. This point 46 is located at 0.25, 0.8, and so this is the x, y, z of that point. Okay. So now I'm gonna, let's say you just want to assign a color to each one of these points. So when I middle click on geometry, or if I click on this eye or middle click, you see that these points that are 260 points, 66 points, they only have one attribute assigned to each one of them, which is P, which is position. Okay. Now I want them to have color as well, but the attribute is not existent. So just be aware of that we generate attributes through while we are working. So let's create an attribute. Can we create an attribute? Yes. If I press tab and I type attribute, so you can find this attribute create, which means, okay, we're going to create an attribute. A quick way of finding things that are like two phrases is just like press tab AC, which you just suddenly moves you to where you want. So I'm going to connect it. So this attribute create doesn't do anything. However, when I middle click on it, or if I press on this I flag or information flag, you suddenly see a new attribute 1 is added. Okay. I press P and I say that instead of attribute 1, I want it to be C, capital C and D, or color data. So I'm going to generate color attribute for this sphere. But color is not a float attribute, is a it's a vector attribute. So it means that it has 3 components. It doesn't have 1 component. We'll get there. I'll explain what is integer, what is float, what is string, and what is vector. So it has a, so let's say it's going to be red. Okay. So RGB is there. So that's one way of creating my assigning colors to each point in my sphere. Okay. So that's one way. I just create another branch out. Let's do another way. Let's say, okay, so this time I'm gonna write a script for that. And the mostly used interface to write a VEX code, a quick VEX code, is attribute Wrangle. Attribute Wrangle, this one. It's just an empty box that you just run your script. I just put the visibility flag on that one. and I just, let's say, you can, like what I have said here, you can say that color data, your color data attribute, when I say at, it means that this is an attribute. Your color data is equal to RGB. R, which is red, is 1, green and blue are 0, and I close it, and I finish it with a semicolon. Okay. I should put that within a crochet. Okay. Because it's I have not defined it as a function yet. I'm explaining to you. So this bendy brackets or curled brackets are a container for the RGB, or just like a package that I put the RGB in it and I generate that. So if I middle click on that, again, you see that I get a CD here, or color data. Here also a color data. So we are doing some very silly things. So like these two ways of doing this is just like was just a silly way of just adding a color. You could say, okay, why you didn't add a color and just make it red? That's it. Basically, that node, color node, does what I did. So if you double click on that, you will see that the color node is basically a Houdini asset. It consists of like multiple layers of nodes, and these nodes, each one, like, oh, you see, oh, there's a bunch of Wrangle nodes here that are functioning underneath. And here you just suddenly tell yourself, oh, did I use all these nodes just to make it red? So then you realize why this one is the fastest, because that's a lot of nodes to do that. So we just wrote our first very basic code, which is just to generate. I use these words very carefully. We generated an attribute, and we assigned that attribute, which was just a color, assigning color to the points. So if you look at, I'm going to make this visible. If you look at geometry spreadsheet now, alongside so each point in space, it's not only have a position, they have a color data, which is RGB as well. So each one of these points has a color data assigned to it. So let's get back. Okay, so we have some data types. So the first word that I was using was attribute. Okay, you will see that I will use attributes and variables. Both of them are data types. Data types are, so let's say you want to generate some information. So, but like we deal with numbers and words, how we categorize them. So first, so if you have a bunch of words and you just want the program to process them as letters, and they're not supposed to do anything than showing a phrase, so they are a string data type. But if you have like round numbers, so like 1, like 1,000, like 256, these are solid round numbers. They don't have any decimals. We call them integers. If you want a number that with a decimal, so let's say like 1, like 23.4356, or minus 1.001. These are float numbers. They occupy more space on your memory. And now if you want to combine multiple numbers together, you get vectors. So if you so we don't have just vectors of 3 components. We have vectors of 2 or 4, but whenever we say vector in general, we mostly mean the 3 components, which is basically most of the time a position or a color or a direction. So when I talk about direction, I am talking about like 3, like in x, in y, and in z directions. But you can have vectors of 4 dimensions or 2 dimensions or more. Okay, so then now that you realize when I said here in this attribute create, when I said vector, it means I just wanted to create color, which is a 3 component attribute. That's why. Okay. So what are functions? So I will, further forward, I will show you more examples of function, but let's get to know them just now. So function is like a computer. So you put some numbers in it, you receive some results out of it. So it's basically, so this is what you have been taught at school. Let me grab my paper. So that you were saying that, let's say, function of x, or you start with this. Y is equal to, let's say, x2 plus 1. This is a function. So let's, instead of y, you could say, this is a machine. This is like a system for generating a lot of outputs. You say function of x is x2 plus 1. Basically, what you mean is that I have a factory, that this factory receives some number here, and then does some work on those numbers. So let's say if I give the factory number 1, it does square that number. 1 by 1 is 1 plus 1 and gives me 2. If I add number 3, my factory does 3 by 3, which is 9, plus 1 is equal to 10. So a function is basically like a toaster. You put bread in it and you receive toast. Or it's like a blender. You add the ingredients in it and you get, I don't know, a sauce out of it. So let's start creating our first function. So I'm going to create a random function in the attribute Wrangle. So you see that I have introduced a new variable here, and then I use that variable in a randomization function. So let's do these step by step. I just want to like do it, you know, step by step, slow and easy. So this is how we do it. I'm just wanna, so you can delete all of that and add a. I'm gonna turn off these point numbers too. Add an attribute Wrangle again, because we have used it. It's already there. So I just click on it. Okay. So I want to say, okay, so here you see that I will start with without introducing a variable. I just say, okay, change the, make randomize color. So my color data, or let's start from the beginning again, at CD, or my attribute that is called color data color, they would be a random number. So rand is a function, is something. You see that it just like when I stop, it gives you some information. It's something that receives something. Let's say randomization of 3. Okay. And it receives something. So you don't know like what 3 means, but it just receives your number, gives back, spits out something. You can put anything. 3. I don't know, 2, 1,000, 2,000, 5. So it basically processes those numbers, randomize them, and then generates a color out of it. But you might say, I just want to assign a random color to each point. So there's one attribute that in Houdini that looks at and gives you each point, and that is called attribute pt_num, or point number. Okay, we just write down color is randomization of point numbers. Okay, so when you might not see it, just click outside and then click back, then you see it. So everything is randomized, right? But it's fixed, it doesn't change. I want something that helps me to change it the way I like. So here you can write down, okay, I want to introduce a new attribute here. So maybe let's say if I write 2 plus point number, I get one number. If I write down 2,000 or 205 plus point number, I get another one. So I kind of realized that working with this, if I would have had, it looks like a seeding number. If I had something here that a thing, so that thing is mostly called seed. So I start to generate that, create it. I type float. I'm going to create a new variable. That variable means something that I want it to be changed. Something that gets shapes of different things. And sometimes it's 1, sometimes it's 1,000, sometimes it's 5.6. So it varies, it changes. So I just type here float, and then I just give it a name, seed. Here I have seed means that it just like it seeds a new change in our little code that we are just writing just now. You can give it a number like whatever, I don't know, 5, and then so this variable has been generated. You have to close your sentence. Say, so in English, you close the sentence by putting dot at the end. In programming, usually most of the time, we just put semicolon here. Say, okay, so I have introduced my variable, which is seed, and it has a number. And I use it here. I say seed plus point number. That's my function. I click it, so it gives me a result. Okay. So if you want to explain your code to the next person that is going to read it, you can press type / and say, okay, this is to create random point color, or whatever you can. And if you just at any point you just want to explain anything more, it's a good habit, because the next person will have a kind of like a good clue about how things are going to progress, and like how they deal with the information that you generate. So here I can say that this is a seed variable for randomization or whatever. Okay, so we just generated a very simple code that randomizes. However, this is static. I have the variable, but I want that little thing that this variable changes. So you see that here I define the variable, and then I used it. You can turn that variable to a channel, which we will explain soon. Okay. So let's go through. So you know what are the basic types of your data type. You know what is a function now. But now we're going to talk about conditions. So what makes us like empowered are first functions and now conditions. Conditions help you a lot, because a lot of times you just ask yourself, what if I do this? What if I put this and then it happens, another thing happens? So conditions are like if then else, or for any number that goes beyond 10, change each one of them like this, or while. These are like conditions. So a simple condition usually has this format. If a condition would be true, then run this code. Else, run another code. You see that you put your condition in parentheses, and you put your codes in curled brackets. Okay, let's start with our first condition. So it's like here you can see like a very simple condition. Who can tell what it is? Liam? Any idea? Mike, the wool? What is it? What does this one says? It's a very simple code. So imagine that we have a sphere in the center. If any point in that sphere would be, on that sphere would be above 0, so let's say this sphere here, okay? So this sphere, some of the points are, so this is y direction, okay? This is point, let's say x. X is this direction, the red one. If any one of these points would be above x0, then the color would be red. If any otherwise or else, if any one of these points would be behind or below 0, the color will be black. So let's generate what we just said. So just say that if, okay, this is our first condition we're gonna create. Easy. If, so you remember that generic format I told you. If then they put the condition within the parentheses, then put the codes that should run or another one that should run in curled brackets. So here we say if any point, P means position of the points. So I'm going to use, in the example it was x, I just want to use y this time. So because I like it up and down, okay? If any position, so it just goes away because the code is not finished. If any position, if any point is, so I'm going to turn these points, if some of these points are above 0, some are below 0, right? So here I would say if any one of these points would be above or above 0, I just don't overcomplicate it yet, then, so open curly bracket and say then then the color of those points would be equal to let's say red, as I said, or let's make it white. 1 1 1. Okay, I should close this crochet, or I say crochet, sorry, because that's, I should close this curl bracket because the first condition is over. Why I move them to different lines, it's not important. You can write them all in one line. So you can write else here, and then another curl bracket, and say then if it doesn't happen another way, then the color data will be 0 black. Okay, I should close this line with this one doesn't close because actually it's like this. Actually it should be like this. So it says if this condition would be true, then the color is white, else the color is black, finish. And then I have to finish the condition. So if you look at that, so if I just want to press, while I am on it, I press Alt E. So it's just like a same window, just big here. So again, if condition 1 happens, actually I'm gonna write them, put them in the this kind of and I'm gonna finish that one. So you can sort them the way you like. I just want to arrange them in this way, as I said here. So you see, a condition is if a condition, which is if any point on this one would be above 0, that's a condition. If that condition would be true, then you get your white color. If that condition would be false, you get black color. So that was our first condition, which is pretty easy. So you can write it in different ways as well. I just skip this because I want to get back to it soon. I just want to write that with another, setup. We step by step, because here things there's no variable introduced. Everything is just like we have written the data attributes on this object. We don't have the flexibility of manipulating it later. So I start with writing them like in this way. So let's write it together. So let's say we try to find out the, create a variable that says what is the position of each one of these points. So I write position float y position, let's say. So this y pose doesn't exist in the board. I just generated it now. I just say that, okay, I'm gonna, you can name it anything. You can say points above water, or points higher, or like higher than 0, whatever, you can call it whatever you like. So I just call it y position at the moment. I do camel casing, you know, the first one small. This is like what programmers like. And I say, okay, so if, so like the y position variable is basically a vector. V stands for vector. A vector attribute, @ stands for attribute, that looks at any point's position in y direction, right? So let me just read it for you again. So this name, which we just invented now, is basically a vector. It has 3 attributes. So if I apply that, let me apply it. So your node here, if I middle click, it already has a position, and that position has 3 components. So basically the y component of that position is what I'm looking at for that y position. Okay, so now you can say that if that y pose I just generated would be above 0, or what if it would be above and equal to 0? You can say that above and equal to 0 to include 0 as well. Then, so when I go to the end of it, you see that like this parenthesis gets highlighted. It means that here is the end of there. Okay, so I open a curly bracket now, and then I press enter. Here, like what I do just now is just to keep the code neat. This is not what you must do. So I just press tab because I just want to tab on your keyboard. Just want to say that if this condition happens, then this, else that. So this just helps me keep things clean. So you can say that, okay, if this condition works fine, then a vector attribute, which is color data, I'm going to set them. Set is a function. Is a function that say, okay, set the color of this point to that. You know, it just kind of like commands the point to be like this. So set the color to, I don't know, red. RGB. How do you know that this is red? Again, as I said, just read it. RGB. Red, green, blue. Red is 1, green and blue are 0. So that's going to be red. Okay. If that happens, that function has already been done. It's going to be red. Let me close the. So you see, the moment I press this this curly bracket, you see that part gets highlighted. It means this is the end of that one. Okay. I come down and I type else. What if it would be not above 0? Then open another curly bracket and I call another. Okay, so that vector color data, let's set it to this time, I don't know, blue maybe, R0 G0 blue is 1, and end of the sentence, and then we close the. We don't need to add semicolon after the curly bracket. So if I apply that, so you see that, Oh, okay. So any points, I'm going to accept that as well. So to any point above 0 gets red, as I said. Any points under 0 gets blue. Actually, what I want to do, I want to add a box here, because box would look cooler with this effect. So, and I make it a poly mesh and make, I don't know, a 16 by 16 by 16 box, and instead of that I use this box. Okay. I'm gonna turn off the numbers. Okay, so what you will see, I'm gonna add a transform, press tab and add a transform node before and one after that. Just want to show you the difference. So let's go to the before one. So you can predict what's going to happen. So I'm going to move this up before that function. So that function looks at our points. Any point above 0 gets what that one says, gets red. Any point below 0 gets blue. But once the function, once the code has been processed, it gets locked in. So if I do movement after that, maybe here, it doesn't do anything like what it used to be. So basically that. So actually you can at this transform node you can type for the rotation on maybe X direction, you can type $FF, which means rotation of this would look at the frames. Press enter, play, maybe +3. I'm gonna turn on the real time. So yeah, I just added like a code that you all know, like, which is frame. Look at this frame, rotate it. So but like you can see that how this code interactively is dealing with so whatever goes, any point that falls under, any point that falls under 0 gets blue. Any points that stays above 0 gets red. We can make it more complicated. Let's bring, let's say that, can you might say, can I say more complicated conditions? Say, what if both, it should be both x and y would be above 0? Okay, so how to mix and match variables. So here let's introduce another variable, float, let's say x position this time. So that variable gonna be a vector that deals with the attribute position of x in x direction. So on y direction was this green, on up and down. X is left and right. Okay, that variable has been generated. I have generated. When you say float, do this, means that you're going to invent, or you're going to generate that variable. That variable doesn't exist. You generate it, and now you're going to use it. So let's say, so when it's above, so I'm going to click Alt E here to open this one. When it's above, in y direction above 0, it gets red, under 0 gets blue. What if we say that if it would be above y and in positive x, it gets green, let's say. So that's a new condition. If let's say if y position is more or equal to 0, look at this one. I say and these two things. It says that the first condition should happen and the second condition, which means like I use the second condition. If these two happen together, so I could say that if y would be above 0, anything above 0, can you see like your numbers here? Houdini is guiding us actually here. So you see here says that this is 1, this is -1. So what if anything that is above both this and means these two conditions, both of them should happen. If both is above 0 and is in positive x direction, then let's open the curly bracket. Then okay, add a green color now. Okay, so add the color data or vector color data. So these two are, at the moment you just think they are the same. If you say v color data or just color data, at the moment you can just say they're the same. So color data set, let's set it to green. Set to R would be 0, G, which is green, would be 1, and blue would be 0. Semicolon, close it, and then close curly bracket, and I'm going to apply that. So you see that it gets green in that area, and you see that it just kind of, we have combined conditions together. Yeah, that was our first simple code to define some conditions. So what you have just done now with these few lines, if you want to do it with nodes, it's going to take like 10 or 15 nodes to be able to do that. So they are quite handy. Okay, so let's move on. So what I just said is basically I just use this. I'm going to review it. So I have introduced two non-existent variables to this word. The first one, actually, give me a second. This snipping tool is a good help here. Okay, I created two non-existent variable. So this one I created that. This one I created that. And I said that this name, it could be whatever, as I said, is basically the position of our points in y direction, which is like up and down. But this name is the position of my points in left and right, x position. Now I said if that would be above 0, so this is 0, anything above 0, give me red. Anything under 0, give me blue. Anything above 0, so it's both above 0 and in positive x, give me green. So this is both happen together. Okay, so so what I have used was this, but like we already know what is greater or less than, what is greater than or equal to a number. This is not, when you want to say if this is not blue, then explode it. If it's blue, keep it. So you can use this sign, which is not equal to. If you want to say if this number is exactly equal to that, if this variable is exactly equal to that number, then use 2 equal sign. 1 equal sign means that assign it. 2 equal sign means if they are they exactly the same? It's asking question. Or this one for or. Okay, so this is also very important to know. I keeps using 2 different terminologies, attributes versus variables. So here, let's go back to Houdini. Here I'm going to apply and accept that. Here you can see that I have created Y pose and X pose, but I didn't use at sign for them. I didn't say float at sign Y pose. I just said Y pose. Variables are temporary placeholders that lives within your attribute Wrangle and then dies. So it just works for you, helps you to run the function. But here you see that I have a new attribute, which is color data. If I middle click here, you see that the color data stays. Attributes kind of rewrite them on the node, and then they stay and flow through. They stay with your nodes. They stay there, and then they move on to the next node. So you see that if I add a transform here, if I middle click on that, color data is still there, but you don't see anything that says Y pose or X pose. So in general, so when you say float a thing so let's say if I would have said float, I think this is gonna be problematic, but I just want to test it. So I turn these two. Yeah, it gives error, but that's okay. Just skip the error. Oh, come on. Oh, I'm gonna create a new Wrangle instead of. Okay. I generate a Wrangle here. So when you say, let's say float thing is equal to 4. So when I middle click on that, that attribute is generated, but like it's not reflected. So that variable is generated, but it's not reflected here. But when you say if at sign thing, F is the first letter for float, you say that I am generating an attribute which is called a thing, and that attribute is 4, and it's going to stick with the object and comes through it. So when I middle click on the attribute wrangle now, you get not only positions but also a thing, and that thing is float. So this is the difference between a attribute and a variable. Attribute stays with your nodes and it goes and it passes on to the next node. But variables, they help you to write your code within the system of the currently functioning wrangle. But then when it's passed on, it just like dies away. Okay, let's do a bunch of practice together. So I'm gonna assign color to different things and see how they work together. So let's start with, like, say that, okay, so I'm gonna start with a maybe a pig head, and then say that don't add any shader, so it would be black and white. So now add an attribute wrangle. So you can say here color data would be, so I'm going to use a new another attribute that you're going to use it a lot. So these attributes that I'm going to show now and practice through, these are the attributes that you keep using them again and again and again. These are important attributes, okay? And I'm going to show you like how to do basic math and basic shuffling around with them. So color data, let's say, are equal to normals. Normals are the vertical line on each, you know what is normal map. So that's our first. So you know that each surface has a normal map. And now you can see that, oh, this pig has a normal map. And I said that, oh, go look at the normal map, read it, and apply it to the color. So if I rotate this pig head on, oops, you see that it doesn't change, okay? But what you can do is say that, okay, so each one of these points has a position. So look at their position and translate it to color. So what I just did now is color data is equal to the position of each point. So now you get this. Position of each point has been translated to color data. So if I rotate that, you see that this one doesn't come through. Actually, I'm going to add a translate node, transform node here to move it easier. So you see that, like, when I rotate it, this blue stays where it is, and it doesn't come along with the pig head, because that's the position data. The blue that I was seeing was the position data that has been translated to color and is there. So, and this one was normal data. So when I rotate normal data, they come along, because normal map is normal map. The angle of it is important. Okay, what else? So you can say that whatever, so color is basically position in X direction. So suddenly you get this. It's because any X that is above 1 gets a color. Anything that is below 0 gets nothing. So you can try, let's say y, you get these interesting results. So basic math, like let's say above y but minus 1, or let's say plus minus 0.1. So you can see that like kind of this distance has been added. But or multiply, star means multiply 1, and then you get like this faded into, or multiply 2, maybe 0.3. So you get this faded into that. What if you say that it's, so you remember from math that, let's say if you want to say this point, attribute 0.1 minus 0.1 multiply 3. So the result that you get, this one, so you are actually, these two work together and this one work alone. So these two, the result of these two is deducted from that one. But what if you want this to happen first, these two? Then you have to use parentheses. You know, these are basic math here. So you put them in parentheses. You say that work on these two, and then the result of these two gets multiplied. So that's going to be different, you see? So these are basic math. So what if, as I said, you can say that, okay, this color, each point, which is PT num is point number, each point number gets a color. At the moment, it's boring, and just 0.0, you see when I rotate, there's a black one. This is 0.0. 0.0 gets black, and any point after that, because they are all above 1, and color, anything above 1 becomes white. So that's why it doesn't show, everything is white except that 1 point. However, you can say, okay, I think I've got like about, I don't know, 1,400 points. So if so let's say, let's go back to our, if this geometry, let's say, has 1, 2, 3, 4, these are, if I have 6, 7, 8, if this geometry has 8 points, these are point numbers, okay? What are these? These are, actually it starts from 0, 0, 1. This at sign PT num is what you just see, okay? But how many points we have? 1, 2, 3. We have 9 points. Is there any attributes that goes and finds the number of the points automatically for me? Yes, there is. And it's called, well, pretty much the other way around. If you just say num point, this is number of the points. But that one was point numbers. So basically, if I so let's say if I divide these together, as simple as that, I get a number that is lower than 1. So if I say that point divided by num points, I get, I'm going to turn this off. it goes all black. The reason is the result here is a float, but this is a vector, right? I say that, okay, convert this vector into float here. If I do that, this point number is a float. Then I get a proper result. Now you see that it's just like different results. So this is called casting. This point number, the number of the points, each one of them, these are floats. These are actually integers. You cannot say this point is 4 point. This one, you cannot say this is point. There is no point that says I'm 0.5. That one doesn't exist. All of them are integers. But I'm with this one, with this float, I have converted integers into float. Now they can be divided and work together. This process is called casting. Okay, can I control that by myself? So can I control any one of these attributes by myself? Yes. So let's say if this point number, instead of that, you would have a, so let's say I wish I had a slider that here I would have moved that slider back and forth and then change it. Yes, you can. So instead of this, you can say that, okay, I'm going to create a channel this time. Channel, and that channel is called a scale. You see that I put that scale inside a this quotation mark. It means that this is a string, as you remember. So when you do that, it gets black because the channel is generated, but you have to see the slider here, but the slider is not there. Just click on that. Oh, you get the slider. Then you can start play around with that. You suddenly see that, oh, the channel is there, but like the function is just so if it goes above 1, suddenly gets killed. So I could say that my channel could be, I don't know, like we have to use another function to fit it, which is all right. Actually, here also we could use a channel here. So let's say we could say that this, instead of, so y position is a channel, and that channel inside is called y. Well, actually, this is what I do. I multiply that one, multiply it. I don't use it. I don't destroy that. I say that, okay, so what if I would have a multiplier here, which is a channel, call it y mult, let's say, whatever. That's a terrible name, but I should put it in a quotation mark and close that quotation mark and then close that. So I generated a channel, and you see that suddenly this one gets all green because the blue goes away, because a channel by default is 0. If I click on that, it's 0. But then I can have this like thing that just can adjust it. So it gives you a slider that you can play around with that slider and just like, you know, get what you want. So when we should use nodes and when we should use you know, codes, there is like, you can look at this. This is a flow chart provided by side effects themselves. Here tells you a very good roadmap. So it says that, okay, so is there any node already created and prepared for what you want to do? So let's say you want to create a scatter or a mountain, or just like, if there's a node for it, it's for a purpose. People has worked on it, so use it. If there isn't any node, yes, you can generate a VEX code. If there's a node, but like it just slows down your work, you just like suddenly realize, okay, this node is too complicated, it kind of slows me down, so you can say that, okay, so I'm gonna write a VEX instead of that node. Or if it doesn't slow you down, just use it. But sometimes it takes more time setting it up a node system than just writing 2 lines of codes. Soon, hopefully, you will get that smart that you say, oh, it's just like 2 lines of code, tack, 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 and then it works faster than 15 nodes. Then just do the coding, and just read through it, and you get eventually to here. Sometimes rendering nodes like slows down your rendering, but if you would have used VEX, this is like kind of, you have to weigh the situation. It's not always that coding is faster. No, some of the nodes that has been generated there are really, really fast and efficient. So you just weigh your results and then and decide based on that. Okay, I just want to talk about functions a little bit more. Yeah. Okay. Then I'm gonna ask you to generate something. I'll ask you some questions, and I want you to make it. Now, I'm gonna talk about functions. So as you just remember, something like a randomization is a function. So you just put something here like point numbers, and it just generates something. But now I'm going to talk about a sine function. What is sine? Actually, if you can't remember the basic math on trigonometry, it's not scary. It's actually very beautiful. If you just have a look at this video, we're gonna watch it together. So I'm gonna stop recording, pause recording, and we watch this together. But just search for Ben Spark. He's a great mathematician, and he explains to you what is a sine or a cosine in math in a very, very beautiful way. So as you saw in that video, so we're gonna a sine function or a set sine function is helping us to create like circular motions. So let's start with like this basic code. I'm gonna start with a like kind of, let's say, a grid. Create a grid, and then maybe, I don't know, 50 by 50, and then add an attribute Wrangle to it, and then say that whatever point is on this I just want to like move whatever point is on this. Actually, let me just not use a. So I'm going to say whatever point is on this grid to be 1. Okay. So see what happens. Suddenly it doesn't give an error, but they are all lost. It's kind of like I have crunched all the points to 1. All the points have been crushed into 1. But the right way of, if you want to move all the points in one direction, it's better to say, okay, so don't kill the points, actually keep whatever they are, just add 1 to them. Okay. So now what you see is, actually it should say, sorry, here, just add 1 to them. So what you see is that all the points have been pushed up, each one of them 1 unit up. Okay, so what you see here is that whatever point you have, keep them, add to them. Okay, so instead of writing that, there's an easier way to write that. Just add a plus here, and that would do the same job for you. So this attribute points plus equal means keep it and plus this number to it. Okay, I can say that keep whatever is equal to sine a frame. So that attribute frame means that look at the frames. Oops. Look at the frames and then look at the sine of it, and then just move it based on the sine of, so let's say frame 178 171, the sine of it would be, I don't know, whatever is, you know that the sine of any number is between -1 to 1. So you can adjust the speed. Let's say if this is like kind of moving back and forth, you see it happens in all directions because it's x, y, and z. But if you want to confine it in one direction, let's say in y direction, you can say that set. So I want to set a number. The first one, x direction. Actually, the x would be, let's say, 0. Y is, or movement up and down is this sine function, and then 0 again, which is the movement in z direction. So now it should just move up and down instead of like all directions. Can I adjust this speed? So you can say, yes, you can divide this sine by, I don't know, let's say 10. Well, it gets slower. Actually, this is just the frequency. Maybe you just bring that 10 inside this frame number, divided by 10. Now you can see that it's way slower. But can I control that 10, turn it into a slider? Yes. You can say that. Okay, remember channel, parenthesis open. You can say channel F, like from now. So CHF means channel. Make a channel which is float, and inside that you can type its scale or speed or whatever you like, speed, and then close it. As I said, channel F, you can use this. Create a channel or a slider, a variable slider, which is what? Float. So that's what I did here. So here I should close 2. I should close it once and then, yeah, okay, because I have opened, I misused, so this parenthesis belongs to that one, but I have to use another, yeah, okay. So now you can see, so when I click on this, looks through your code, finds anything with channel and creates a slider for it. So at the moment speed is 0, but you can just like adjust the speed. Make it fast or slow. So that one is very handy too. You kind of create an interface, a GUI, GUI or GUI. These ones create an interface or GUI for your code. Actually, even if you're coding for yourself, this is very handy because you just want to, like, sometimes you say, I just want this number to be available to me, and I just change it up and down. Okay. So if you remember, we just talked about like how to, if you create a variable, let's say, you can assign. So let's start with something like this. As well, we just covered this. So let's say what we see here. I just want to create a variable that is called length. Okay, and then I want that length, assign it to a color. Assign a sine color. Actually, it would be very beautiful to use sine on an object for the coloring. So let's say if you say okay, let's start with introducing that length. This is called a new attribute. I call it length or distance or whatever. Let's call it D. Stands for distance. This is, you see that like when I type length, it already exists. It means that this is a function that goes and grabs the length of any point that I say. So here, what this function does, so you see that you've got plenty of points here. It just goes, okay, what is the distance of this point from 0, from like the origin? Calculates that distance and using the length function and gives me a number. Okay, now I'm going to use that number. I say, okay, that D is basically, don't take it, so don't kill them, don't make them 0. So that's why, so I just say add to them, whatever they are, add to them and turn them into a channel. I should say scale. Again, how I'm going to write this in another way. So I just used / because I don't want it to function. So the other way is basically I just said D is equal to whatever it is now, which is D, plus a slider here, a slider down here. Let me just delete all of these sliders. Just click here and just delete all spar parameters. I just want a slider to be generated here and slider. And I grab that slider, move it around, and then add to the current number again and again. So that's what I just created there. That's what I just said there. And then you just say that, okay, now go and get that distance and convert it into a color. This is color. And let's start with the just say, okay, go get it and make it D. Just turn that off. So that distance from 0 to 1 has been, so I'm going to create that scale. You see that that slider kind of fades away. This is very boring. However, if that beautiful sine shows up, so you just say, okay, now I just want the sine of D. How would that look like? Then suddenly you get D, which is pretty cool, but it doesn't change. But when you play around with this scale, you just see it. Oh, that's too much. You just see it's changing. I could type here $FF and then play. Oh, that's too fast. $FF divided by 5. Beautiful. So that's the sine of D. You can adjust it. You can just say that, okay, so the sine of D plus 1, how would that look like? And then like divided by half. That gives like this kind of larger rings. So it's, you just saw I just was playing around with that. So I had this slider here and I just used it. Right? Okay, so I want you to, so this is our first practice. I want you to, so you see that here I have, there are a lot of familiar things. There's, I just don't want to talk about this. But we only have one new function. So you saw me using function length, which is the distance between any point to origin. This is function distance, which is the distance between 2 points. I want you to create this code and then explain me what is it doing. I just want you to describe the structure and the function of it. Okay, I give you, I don't know, 5 minutes to figure it out. Okay.